Question 8. Plants are sold in 3 different sizes of tray. A small tray of 30 plants costs $6.99, a medium tray of 40 costs $9.45, and a large tray of 50 costs $10.99. Maria wants to buy the tray of plants that is the best value for money. Which size of tray of plants should she buy? You must show all your working. So for these best value for money questions, we need to look at how much each plant costs. So if we're looking at small plants, it's $6.99 for them, and there are 30 of them. And if we work that out on our calculator, it is 0.233 pounds. So that's just over 23 pence. If we then look at medium, do the same calculation. I'm going to do this for all 3 of them, and then compare the figures and find which one's the cheapest. This one's slightly more expensive. And then if we go to a large, look at the large ones. They are $10.99, and they have 50 in a pack, which means they are 0.2198 pounds. So we can write a conclusion then, something like Maria needs to buy the large tray since plants in that tray cost below 22p, whereas the other sizes, each plant costs more than 23p. So we need to write it out as a sentence, just like this, because of this little star here. That tells us we need to do some written communication in the question. Question 9. This is going to be pretty difficult for me to illustrate, but I'll give it a go anyway. It says, use ruler and compasses to construct the perpendicular from point P to the line MN. You must show all your construction lines. So first things first, we're constructing it, and we're constructing a perpendicular, which means a line that meets another line at 90 degrees. So the way that you would do this is you would start by putting your compass point on M and stretching it out to P, and then you would draw yourself an arc above the line at P and then below the line. So if I draw in what that arc could possibly look like, you'd have an arc there and then something like that down there, and then you would do exactly the same, but this time you put the spike of the compass on N and you draw yourself a arc through P and an arc through there. So you would measure out the distance from N to P with your compass, put the point there, the end of the pencil there, an arc at both, and then you join both points up, this point and this point, join them up with a ruler, and that would give you your perpendicular. So the finished result would look something like this. Question 10. The equation x cubed minus 6x equals minus 1 has a solution between 2 and 3. Use a trial and improvement method to find this solution. Give your answer correct to 1 decimal place. You must show all your working. Okay, so for this one we just need to set up a table. This will make it easier with what we're going to try as x, our equation, so x cubed minus 6x, and we've got to see if it equals to minus 1. So we'll also then make a judgment. If I put in, it's between 2.2 and 3, so I'm going to put in 2.5. When I put that in, I'm going to get 2.5 cubed minus 6 times 2.5. I'm not going to do this every time. I get the answer of 0.625, which is too big. We're trying to hit minus 1, so we're going to have to use a smaller number so that we get closer to minus 1. So this time I'm going to try 2.4, and when I substitute it into that equation, I get an answer of minus 0.576, which again is too big. We're trying to get down to minus 1. So now let's try 2.3, and this time we get minus 1.633, which is too small this time. So that's what we want. We want two numbers next to each other where one's too big, one's too small. So we know that the actual answer is somewhere in between those two. Now you might think, oh, this one's only about 0.4 away from -1, this is 0.6, so it's probably closer to 2.4. But for us to get full marks, we have to prove it. So we have to show that whether 2.35 is too small or too big, and we'll make our judgment from that. So having substituted that in, I've got -1.122. There's a few more decimal places, and that is too small. So if that's too small, then our answer needs to be bigger, which means that the answer to 1 decimal place is 2.4 to 1 decimal place. Question 11. Part A asks us to solve 6x squared equals 249. So we just need to unwrap this equation. I'm going to start by dividing by 6, which will leave us with x squared is 294 divided by 6, which means that x squared is 49. And then to find out what x is, we have to do square root of 49. So we get that x is 7. Here, next one, we've got w to the power of 8 divided by w to the power of 2. So w to the power of 8, that's w times itself 8 times, and w to the power of 2 is w times w. And I've written them as a fraction so that we can cancel them off. And so we can see that when we cancel out 2 of them, we're left with w to the power of 6 as our final answer. Let's move on to part C. We've got 3a cubed c times 5a to the power 4 c to the power 4. So for each one we're going to multiply them together. So we've got 3 times 5, which is going to be 15. A cubed times a to the power 4 is a to the power 7. And c times c to the power 4 will give us c to the power 5. And then part D, we've got a cubed to the power 4, which means a cubed times a cubed times a cubed times a cubed, which is going to give us a to the power of 12. So you can just, when you're raising a power to another power, you can multiply those two numbers. Question 12. Part A asks us to describe fully the single transformation that maps shape A onto shape B. So we need to describe what's happening here, and they're even asking what type of transformation it is. So the first one, nice and easy, it's an enlargement. That's going to give us 1 mark. And then we need to say what the scale factor is, and we also need to say what the centre of enlargement is. We can tell the scale factor by just looking at it. We're going from A onto B, so this is the original shape, and it's gone up to this shape. If we compare a side length, so this bottom side length here is 2. If I then compare that to this side length here, got a side length of 8, so to get from 2 to 8, I'd have to multiply it by 4. So my scale factor is multiplying by 4. And then to find the centre of enlargement, we need to draw with a ruler, join them up the corresponding points. So this point I'll join up with this point. I'll carry that line on. I'll do the same for a couple more points, so these two, and I'll probably do it for these two as well, and see where all those lines converge. So I've drawn in those ruler lines, and we can see that they all converge around this point here. So that's the coordinates of our centre of enlargement. So I'm going to give that as a coordinate. The x coordinate is 1 and the y coordinate is 1. So centre of enlargement 1, 1. Part B, here we've got a different transformation. It says on the grid, reflect shape A in the line y equals x. Now, there aren't any lines drawn, so we need to draw in this line y equals x. And if you're not sure what that looks like, that's a diagonal line that goes through at 45 degrees, so y equals x. So if you wanted to work it out, you could say when x is 1, y is also 1. When x is 2, y is 2. When x is minus 5, y is minus 5. And you could plotting those points and join them up with your ruler. So I'll just plot those in, join them up with a ruler, and we'll reflect the line, the shape in that line. So I've drawn in our line. Now we want to reflect the shape. So if I was going to be doing this in the real exam, I would put some tracing paper down. I would trace around this shape. I'd also trace around the line here. I'd then flip over the tracing paper, and we'd see that you'd get a shape. The shape would come out in this area here, so I'm going to draw that in now. So that's where the shape would be. The other way of checking would be to make sure that these corresponding corners are passing perpendicular. If I drew a line between them, the line would be perpendicular to the mirror line. So I'm going to draw in a couple of those just to show you. So I've just drawn in a couple of the lines, joined up this point with this point, and then this point and this point. We can see that we are forming a 90-degree angle here between the lines and the mirror line. Question 13. We're given the inequality -8 is less than 2n, which is less than or equal to 2. And it says that n is an integer. It asks us to write down all the possible values of n. Okay, so there's some number that multiplied by 2 is greater than -8 or less than or equal to 2. Saying it's multiplied by 2 because we've got that 2n is between these two numbers. So if we then divide the whole thing by 2, we're going to get -4 is less than n, which is less than or equal to 1. Sorry. So now we just need to write all of the numbers that n could possibly be. N is an integer, so it's a whole number. It's not 4 because it's not included in this inequality. So the next number up is -3, -2, -1, 0, and 1 is also included because this is an inclusive inequality. Okay, part B. It says solve 3x minus 3 greater than 7 minus x. So I like to treat these just like an equation, and so I'm going to rearrange so that the x terms are on one side and the constant terms are on the other. So we start with 3x minus 3 greater than 7 minus x. I'm going to add x to both sides. That'll get rid of this. So if I add x, I'm going to end up with 3x plus x minus 3 is greater than 7. That means we've got rid of this minus x here. Then want to get rid of this minus 3, so I need to add 3 to get rid of that. So these two, 3x and x, is going to be 4x is greater than 7 plus 3. So 4x is greater than 10. Just going to continue it up here. So then x is greater than 10 over 4. Could leave it as a fraction, or you could do 10 divided by 4, which will give you x greater than 2.5. Either of those solutions are appropriate. Question 14. Sophia has £15,000 to invest in a savings account for 2 years. She finds information about two savings accounts. There's the fixed rate, compound interest 2.5% each year, or the super saver, which gives compound interest of 3% for the first year and then 1.5% each year. Sophia wants to have as much money as possible in a savings account at the end of 2 years. Which of these savings accounts should she choose? So we need to calculate both accounts and see what she'd have after 2 years. So if we have a look at the fixed rate account, there's a 2.5% increase each year. We need to work out what our multiplier is going to be for this. There's an increase, so we start with our 100% and then we add on 2.5%, and that gives us 102.5%. So each year we're going to get 102.5% of what we had the previous year. Turn that into a decimal multiplier. That's 102.5 divided by 100, which is 1.02. 1.025, and that's going to happen for 2 years. So we take our £15,000 and we multiply it by 1.025 twice. So put it to the power of 2, or we could write it as 15,000 times 1.025 times 1.025. Either way, we're going to get the same answer. The answer that we get is £15,759.38. I've rounded that to 2 decimal places because it's money. And now we need to see what figure we'll get from SuperSaver. So if we look at the SuperSaver account, it's 3% for the first year. So that's going to be a multiplier of 1.03, and then for the second year it's going to be a 1.5% increase, which is 1.015. So we're going to do 15,000, multiply it by this multiplier here, so 1.03 times 1.015, and that gives us a final amount of money, which is £15,681.75. So for the final part, there's a star by the question number, so to show some written communication, need to say Sophia should choose the fixed rate because she will get £77.63 more. Question 15. The table gives information about the temperature at noon in a town for 50 days. And part A asks us to calculate an estimate for the mean temperature. So we're going to be estimating a mean from this group data. And the way that we do that is by stating the midpoint of each group. So I'm going to do that now for each one. This one will be 10, 14, 18, 22 and 26. And then with those, we're then going to multiply our midpoints by the frequency. So we're going to multiply these numbers together. And that will give us a new column. So I'm just going to fill out this column here. And then finally, to find the mean, we need to work out the total of this column here, which when we add them all together, we get 944, and also divide it by the total of the frequency, which when we add those together, we should get 50, which is the same as what it said in the first place, 50 days. So then finally, the mean is going to be 944 over 50, which is 18.88 degrees Celsius. Part B. Danny says that on at least a quarter of the days the temperature was less than 16 degrees Celsius. Is Danny correct? Well, firstly we need to work out what proportion were less than 16 degrees Celsius. So the groups that are 16 degrees Celsius and below are the ones above that red line. So this first group and this second group, and the total there is 4 plus 9, so there were 13 days where the temperature was less than 16 degrees. So 13 over 50, if we do that as a percentage, so then times that by 100, we get 26%. And then if we compare that to what Danny said that at least a quarter were less than 16 degrees. We found that 26% were less than 16 degrees. So 26% is bigger than 25%. So Danny is correct in this case. Question 16. A, B, C and D are points on the circumference of a circle, centre O. AC is the diameter of the circle. AC and BD intersect at E, angle CAB is 25 degrees and DEC is 110 degrees, we must work out the size of DAC, and we need to show all of our working. So we're trying to find this angle here, DAC. Let's call that X. And we need to use circle theorems here to find out what X is. The first thing I can see is that this triangle here, CAB, is a triangle that's in a semicircle. So that means that it's a right angle triangle. And so I need to show that because it's asking me to show all our working. So angle ABC is 90 degrees because of it's an angle in a semicircle. And then from that we can also work out this angle here, and that is going to be 90 plus 25, and then 180, take away that because of angles in a triangle, and that is 65 degrees. So again I need to say that, so angle ACB is 65 degrees, angles in a triangle sum to 180 degrees. And then using the angles in a same segment theory, this angle here, which is the 65 degree angle that we just found, is the same as that angle there. So I'll label that on the diagram as 65 degrees. So I'm going to say angle ADB 65 degrees. The reason is angles in the same segment. One more step to go before we can get X. We have a triangle here, so AED is a triangle, and we know that this angle here is 70 degrees because it's on a straight line with 110. So again I'm going to state that, so angle AED is 70 degrees because angles on a straight line sum to 180. And then finally we can say what X is. X is 45 degrees, and the reason for that is that angles in a triangle sum to 180. Question 17. The volume of Venus in meter cubed is 9.28 times 10 to the power of 20, and the volume of Mercury is 6.08 times 10 to the power of 19. How many times larger is the volume of Venus to that of Mercury? Give your answer correct to 3 significant figures. So we're going to have to do a division here with standard form. So we've got 9.28 times 10 to the power of 20 divided by 6.08 times 10 to the power of 19. Well, what we can do here is cancel out these powers. So 10 to the power of 19 will cancel with 10 to the power of 20 and leave us with 10 to the power of 1. And so we're going to be left with the fraction 92.8, because that's 9.28 times 10 over 6.08. And when we work that out, we're going to get 15.2631. And we want it to 3 significant figures, so I'm going to look at the third figure, assess this one here, is that 5 or more? If so, I'm going to round it up. It is 5 or more, it's 6, so this 2 is going to become a 3, so it's 15.3 to 3 significant figures. Question 18. L1 and L2 are perpendicular lines. The equation of L1 is y equals 2x minus 1, and L2 passes through the point minus 4, 2. Find an equation for L2. So the first clue that we've got here is that they're perpendicular lines, which means two lines that meet at 90 degrees. The equation of L1 is y equals 2x minus 1, and L2 passes through the point minus 4, 2. We need to find the equation of L2. So we know that the gradient of perpendicular lines, so the gradient of the first multiplied by the gradient of the second, will give us a product of minus 1. So that means that the gradient of L2 is going to be something that multiplies 2 to get minus 1. It's going to be minus a half. And then we need to work out what the y-intercept is. So we have this so far of our equation. It's minus half x, but now we need to work out c. This is for L2. The way that we can do that is by using this point that they've given us. So if we substitute in minus 4 and 2 into this equation, that'll tell us what c is. So y is 2, that's here, and equals minus a half times minus 4, that's what x is, and then add c. So 2 equals minus a half times minus 4 is going to be positive 2 plus c. So then rearrange it so that c is the subject of the formula. We have 2 take away 2, which is 0. So now we just need to write out the equation. If c is 0, we don't even need to include it. So we're going to get y equals minus a half x. That's our final solution. Question 19. The students in a class kept a record of the amount of time in minutes they spent doing homework last week. The table shows information about the amount of time the girls spent doing homework last week. So we've got the least amount of time, the range, the median, the lower quartile and the upper quartile. And part A asks us to draw on the grid a box plot for the information in the table. Now for a box plot we need 5 pieces of information. So we need the lowest value, we need the highest value, we need the lower quartile, we need the median, and we need the upper quartile. And from this information we've got the least amount of time, got the median, the lower quartile and the upper quartile, but we don't have the highest amount of time yet. But what we do have is the range, and the range is the highest take away the lowest. So something, the highest, take away 60 gave us 220 as our range, which means that our highest is going to be 280. So we need to plot that one in on the grid as well. So I'm just going to go ahead and draw that in. So I've drawn in all the information and connected it up like the box plot should look. Try and use a ruler. I obviously haven't used a ruler for this, but I'm stuck to the scale. I'm right on the line where I should be. Now let's move on to the second part of the question. It says the box plot below shows information about the amount of time the boy spent doing homework last week. The question asks us to compare the amount of time the girls spent doing homework with the amount of time the boys spent doing homework. So from this we're going to have to work out all the times. So the least amount of time here is 40. The lower quartile is 120. The median is 190. Upper quartile is 225. And the highest is 250. Now the main things to do when comparing box plots are to compare the median and the interquartile range. Sometimes you can also include the range. This one's only 2 marks, so I'm just going to compare the median and the interquartile range. So looking at the median for both, the boys' median was 190, the girls' median was 160. So I can say that the boys spent longer on average because their median was higher. Now I'm going to compare the interquartile ranges. So for the boys, the interquartile range is 225, take away 120, so that is 105. And for the girls, if you look back at their data, their upper quartile is 220, the lower quartile is 100, so the interquartile range of the girls is bigger at 120. So from that we can say the girls' results are more spread out because their interquartile range is bigger. So a couple of sentences like this, some comparisons showing the actual figures is going to help make sure that you show the figures rather than just saying that they're bigger. Show that we've worked them out. 120 is bigger than 105. That should get us the full marks on this question. Question 20. A town has a population of 140,000 correct to the nearest 10,000 and an area of 56 kilometers squared correct to the nearest whole number. It asks us to write down the upper bound of the population. So the population is 140,000 and that's rounded to the nearest 10,000. So the nearest 10,000 below that is 130,000 and the one above that is 150,000. We're looking for the upper bound, so we're looking for the number that the highest number that could possibly round down to 140,000, and that is 145,000. Part B. Work out the upper bound of the population density. You must show all of your working. So, first tricky thing here is to work out what the population density is, but there's a clue in that the unit is given as people per kilometre squared. So that means we're going to be doing the population divided by the area. So to get the upper bound, we need to make this number as big as possible and this number as small as possible. So we're going to be using the upper bound divided by the lower bound of the area. We've already worked out the upper bound of the population, that's 145,000. And then for the area, we're told that the area of 56 kilometres is correct to the nearest whole number. So we've got 56 and the whole numbers next to it are 55 and 57. And because we're looking for the lower bound, we're looking for the lowest number that would round up to 56, and that is 55.5. So we're going to divide this by 55.5, and the upper bound for the population density is 2,612.612613. Now, because we're dealing with people, I'm going to round this to the nearest whole number, so that's 2,613. Question 21. It says, show that n plus 1 squared minus n minus 1 squared is an even number for all positive integer values of n. Now, because we have to prove it for all positive integer values, if we put in a random number, say 4, and work it out, and we get an even number, doesn't mean that we've proved it for all integer values. So we need to work this out using algebra. So n plus 1 squared is the same as n plus 1 times n plus 1. And then we're going to be taking away n minus 1 squared, which is n minus 1 times n minus 1. So we need to expand both of these brackets. This one's going to be n squared plus 2n plus 1, and then we're going to be taking away n squared minus 2n plus 1. Now the reason I've been using these square brackets is because we're going to be taking away all of this bracket, which means this minus 1 is going to be multiplying every term in this square bracket here. So I'm going to do that now. This will be minus n squared, minus 1 times minus 2n is going to be plus 2n, and then minus 1, and that's going to be taken away from this expression here. And if we collect the like terms, we've got n squared minus n squared, they'll cancel out. We've got plus 1 minus 1, they'll also cancel out. So we're just going to be left with 2n plus 2n, which is 4n. Now, an even number is a multiple of 2, so if we take 2 out of this, we can show that whatever value we substitute in for n is going to be multiplied by 2, and so will be a multiple of 2, and so will be an even number. So I've just written out a sentence explaining what I just said there. Any integer value of n will be a multiple of 2, and so is an even number. Question 22. 164 students sat a test. Each student attained a grade A, B or C. The table below gives information about these students. A teacher takes a sample of 50 of these students. The sample is stratified by gender and by grade attained. Work out the number of students in the sample who are female and attained a grade C. So if it's a stratified sample, that means it's going to be proportional to the population. So we're looking for the students who are female and attained a grade C, so that's this. The proportion of females that attained a grade C in the whole class were 12 out of 164. And if we have a sample of 50, to work out how many are in that sample, you have to multiply it by the sample size, and that gives us 3.65853 recurring. Because we're talking about people here, we need to round it. I'm going to round it to the nearest whole number, which is 4 people. Question 23. Solve 3x squared minus 5x minus 3 equals 0. Give your solutions correct to 3 significant figures. When we're solving quadratics, sometimes we can factorise them, but when we're asked to round, it's quite a good clue that it's going to be very, very difficult to factorise, and it's more appropriate to use the quadratic formula, which is minus b squared plus or minus the square root of b squared minus 4ac over 2a. So we need to state what a is, what b is, and what c is. A is the coefficient of x squared, so a is 3, positive 3. B is the coefficient of x, which is minus 5, and c is the constant term, which is minus 3. Then we need to substitute them into this formula, and we'll get 2 different answers when we either do plus or minus. So the first part, we're going to get x equals minus 5 minus b minus minus 5 is plus 5, so that's going to be 5, and then on this side I'm going to do plus, and on this side I'm going to do 5 minus, and that's going to be over 2a, so 2 times 3, which is 6. Now I've left the square root at the moment because this is always quite a tricky part, and if you do it straight in your calculator you normally come up with some sort of BODMAS error. So if I do it separately down here, b squared is minus 5 times minus 5, so that's 25. And then we have minus 4 times 3 times c, which is minus 3. So that is minus 4 times 3, which is minus 12, times minus 3 gives us plus 36. So inside of that root sign we have 61. And then if we work out both of these on our calculators, this root where we use plus gives us that x equals 2.1350, etc. And the other one is x equals minus 0.46837, etc. And we want to round them to 3 significant figures. So I'm going to cut that one there and going to round this one here as well. This number tells us to round 3 up to a 4, but this 3 tells us to keep the 8 the same. So our two solutions are x equals 2.14 or x equals minus 0.468.